Hello, this is the demo video for ELEC 327 Spring 2016 Super Electronic Safe Final Project. Let's meet our team members. Here's Caleb on the left, Erica in the middle, and Jason on the right. Nowadays, many traditional devices have gone digital, such as a digital scale, a digital wearable device. However, we found that old-school safety boxes haven't gone through a lot of update. So we're driven by the digitalization of traditional devices, and we wanted to update outdated safety deposit box. By virtue of an MSP430 microprocessor, this new device not only incorporates the traditional button pressing password entry system, but also can be remotely controlled via Bluetooth and a compatible Android app which employs voice recognition. Besides, it will have an anti-theft system that detects abnormal motion and alarms the owner with sounds and lights. This is the basic design of our safety box. Our safety box has multiple modules. This password entry module will be used for the user to enter the passwords by pressing the buttons. And 8 LEDs will be used to display the password entry. The Bluetooth module is responsible for communicating with the cell phone. This IMU module includes an accelerometer that detects any motion of the safety box. The servo motor will be used to lock and unlock the door of the safe. There will also be another servo motor inside the box that will be responsible for opening and closing the door. Let's go through the parts we used to build this super safe. The LED strip and the membrane keypad are placed on the top outer surface on the top of the super safe. Inside the safety box, there is a main PCB with a buzzer mounted onto it. And on the left, you can see there is an accelerometer, a Bluetooth module, a 4 AAA battery pack. And on the right, there is a servo motor that is used to control the door. And there is also a servo motor that is used to lock and unlock. The HS422 motor is used to lock and unlock the safe. It has a lower torque and an operating voltage of 6 volt. It is controlled by the pulse width modulation of frequency 50 Hz. A pulse width of 0.9 millisecond is used to lock the safe, and the pulse width of 2.1 millisecond is used to unlock the safe. The PWM is generated by timer A1, channel 1. The FS5109B motor is used to turn the safe door. It has a high torque and operating voltage of 6 volt. The PWM frequency is also about 50 Hz. The pulse width of 0.7 millisecond is used to close the door, and the pulse width of 2.3 milliseconds is used to open the door. The PWM is generated by timer A1 channel 2. The Bluetooth module uses the Bluetooth 2.0 protocol, and this module communicates to the MSP430 via UART communication. The TX on Bluetooth module is connected to the receive on the MSP430, and the signal transmitted from the cell phone to the Bluetooth module will be used by the MSP430 to control the behavior of the safe. The gravity sensor, also known as an accelerometer, is used to detect any violent motion of the safety box. It allows 3-axis detection. The analog readings are converted to digital via MSP430 ADC10 module. The membrane keypad is placed on top of the safe. It consists of an array of 4 buttons. There is one common ground header pin. The debouncing time of the buttons is about 32 milliseconds. and the buttons are used for the users to enter the password. A piezo buzzer is mounted onto the PCB, which is placed inside the safety box. When theft is detected, the buzzer will ring an alarm. The buzzer tone is controlled by the timer A0 channel 1 PWM. An array of 8 APA102 SPI LEDs are mounted onto the top of the box. These LEDs are controlled via slave in master out SPI communication, supported by the MSP430 Universal Serial Communication Interface B0 module. They are used to indicate successful Bluetooth command reception, keypad password entry, correct wrong password detection, and also password reset and theft alarm. A 4-piece battery pack is also placed inside the safety box. They are used to power the servo motors with 6 volts, and they share the same ground as all other parts. Now let's get to the remote-controlled Android app, SuperSafe Remote. You will need this Android app to open the safety box. We developed this app from scratch. It uses voice recognition using the Google API, and one can say, open the safe, close the safe or lock the safe, and reset password. And the app will use the Bluetooth from the cell phone to send the opening, closing, or the password string to the MSP430, and the MSP430 will control the safe box. One can download the app from the Google Play Store. Please see more details in our report. Now it's the most exciting part, working prototype. We will give instructions for you guys how to use this safe box and the Android app. First, the user will need to send an open command by using the remote control app. Upon receiving the control signal, 8 LEDs on top of the safe box will be on together for about 0.5 seconds. After the LEDs are off, the user can enter the password by physically pressing the buttons. The password will have a length of 1 to 8 digits, and the LED will be on to indicate successful entry of the current digit. Once the entire password is entered correctly, the LEDs immediately display an open animation, and the safe unlocks and opens automatically. If the password entered is not correct, the user has to keep pressing the buttons until all 8 digits are entered and the LEDs display a wrong password animation. This mechanism is to make it secure that the person entering the wrong password will not get to know the true length of the password. When the password is being entered, if there's no button pressed for 2 seconds, the password digits that have been entered will be removed, and the user has to start entering the password from the first digit. This is indicated by switching off all of the LEDs. This timeout situation will not be considered as a wrong password entry. The safe will automatically close and lock if the user presses any of the 4 buttons on the keypad or sends a close signal via the remote control app when the safe is open. The user can also change the password via the remote control app. After the password reset command is recognized by the Android phone, one can enter the new password that contains digit 1, 2, 3, or 4, and has a length of 1 to 8 digits. If the password is reset successfully, the LEDs will be on for about 0.5 seconds and indicate the length of the new password. Here comes the most interesting part of our prototype. If someone tries to forcibly open the safe without a correct password or tries to move it, boom, the alarm system will be triggered and inform the user of the theft. the buzzer will sound and the LED strip will light up a warning pattern. This alarm will be on by default for 10 seconds, after which the safe will be locked and the user has to use the remote control app if he or she wants to open the safe again. Also, 5 consecutive wrong password entries will lead to the same alarm situation. This is super safe. The user has to use the remote control app before he or she will be able to enter the password, and then he or she must enter the right password, and the true password length is never given away. Also, if the wrong password is entered 5 times consecutively, a theft behavior will be detected and the alarm will ring. Also, since we have an accelerometer that is constantly detecting any motion of the safe box, no one will be able to move the box without raising the alarm. Thanks for watching this video. If you are interested in our project, check it out here in the GitHub page. And also, you can find us on YouTube. There is an amazing advertising video of our project. And the last thing, here's are all the links to the parts we used in our project. Thanks for watching this video.